Okay. Anyway, this is from homework. We start from homework. Homework question. Number 13. This is section 20.5. Right? Page. $13. So solve for x in this interval. So it's just in the four quadrants. Number 13 is sine of 2x sine x plus cos x equal to 0. Okay. Are you following me? You see my page? Thank you. Okay. Let's try to solve this. Thank you so much. The only problem we have is the angle is mixed up. Some of the functions it's x, some of them it's 2x. So I would rather have them the same, like either 2x or x. It's better here to change it by we know that, right? We know that double angle formula of sine 2x could be written as 2 sine x cos x. This is something we learned from section 3. And then this implies sine 2x is 2 sine x cos x. That's only sine 2x. There is sine x multiplier there, plus cos x equal to 0. So, in other words, this is 2 sine squared x cos x plus cos x equal to 0. Now, you remember, it's always a new question is a new challenge, really. You don't know what you're going to get. Like, so what methods you're going to use is not consistent. It depends on the question. So in my case, I see it, then I can factor cos x and then solve, because the good thing is the right-hand side is 0. So if I factor cos x, I got 2 sine squared x plus 1. And then there are 2 functions multiplied. And then each should be equal to 0. That's where we get 2. So cos x equal to 0, comma, 2 sine squared x plus 1 equals 0. So cos x equal to 0, comma, sine squared x. Is really true? Is that what we have? Well, unfortunately, sine squared of x equal to 1/2, right? Oh, minus 1/2, right? Which is impossible. Really, because, well, then it will be sine of x equal to plus or minus square root of negative 1/2, which is undefined, all right? So it's impossible. So only a solution we're going to get is from here. Let me double check my arithmetic, okay? Sine 2x is 2 sine x cos x. 2 sine squared cos x plus cos x equals 0. The factor cos x, you get 2 sine squared plus 1 equals 0. And then cos x equals 0, and then 2 sine squared plus 1 equals 0. Sine squared x is minus half, right? Sine x is undefined. So sine x equal to 0, of course, it's very easy. Sine cos x equal to 0 where? It's on the vertical. If this is 90, or this is 270, right? So x must be pi by 2, and then 3 pi by 2. So from here, we get nothing. So these are the only solutions. I don't know. Yeah, that's it. They did that on purpose. I checked the answer. That's right. Pi by 2 over 3 pi by 2. I thought they made a mistake here. If they have made this minus, if this was minus, there would have been a lot of other answers. But that's right. Okay, let's see what your comment was. Well, a square number can never be negative, Trevor. A square number, something square can never be negative. A square number, the least it can be is 0. So it's impossible. Even if I say x squared equal to -½ it's wrong. There is no x which satisfies this. You will never give me an x where it's a square number is equal to negative. A square number is always positive and 0. The least it can be 0. As soon as I saw the sign squared equal to negative, I know something is not right there. Okay. So why is it considered impossible? Is that okay, Trevor? Okay. Okay, what's it? I don't know. Let me see if we have any quadratics. Double check my notes. Let's do number 17. I don't know if number 17 here is the same as. So solve for 10x, solve for x. So for 10x minus secant squared of x equal to 0, for example. So the problem here we have is the tan and secant. I cannot say, oh, okay, x equal to somewhere unless I make them of the same function and then try to solve for the x. Before I find the x, I have to resolve the functions. Functions are tan, secant. So I think it's very smart to change this into a function of tan. Change this into secant squared of x as a function of tan. Which is 1 plus tan squared, which is, yes. So this is 4 tan x minus 1 plus tan squared of x equals 0. So this looks like a quadratic function, which is, what is it really? Minus tan squared of x minus plus 4 tan x minus 1 equal to 0, isn't it? Minus 1 minus tan squared. Or you can multiply both sides by negative sign, then you have positive tan squared x minus 4 tan of x plus 1 equal to 0. This is, for me, this is a quadratic equation. This is quadratic equation of what? X? No, quadratic equation of tan x, right? So if you really, in other words, what I'm saying is y squared minus 4y plus 1 equals 0. You're really doing, if y equal to tan x. If y equal to tan x, this is what you're doing. Isn't that a quadratic equation? Yes. So then you're going to go further. But in other words, okay, if y equal to tan x, then y squared minus 4y plus 1 equals 0 is the quadratic. But I will just factor is the way it is. Tan squared is tan x times tan x. 1, oh, you cannot factor. That's not easy to factor. It's not factorable. 1, you cannot write a product of 1 to give you -4. Okay, so what we could do is quadratic formula. Use quadratic formula to solve. So the quadratic is, you know, your A is what? 1. Your B is -4. A is 1. B is -4. C is equal to 1. And then your function or your y is tan. Tan of x is equal to minus b. You remember the formula? Minus b plus or minus square root of b squared minus 4ac over 2a is a quadratic formula. So this is minus b minus 4 plus or minus square root of b squared, which is 16, minus 4a is 1, c is 1. So over 2a, 2 times 1. So this question is reduced to tan of x equal to plus 4 plus the square root of 12 over 2. 16 minus 4 is 12. So far, okay? So you can even do better, 4 plus or minus. Okay, root of 12 is 2 root 3, right? Root of 12 is 4 times 3, which is root of 4 times root 3, which is equal to 2 root 3 over 2. Then you can even reduce this into 2 by 2. 4 is 2 by 2. The 2's cancel, plus or minus root 3. That's what it is. So tan x equal to 2 plus root 3 is 1. Tan x equal to 2 minus root 3, another case. You have to solve these two cases. So far, so good.
Sir, can we use the calculator, I mean the equation function, to find the values of x? Is it allowed in this class, or we have to find it manually? Thank you.
Yes, you are, but then you will get only reduced number of angles as a solution. They're not going to be all of them.
I mean the x values that we got is 2 plus cube square 3 and 2 minus square 3.
Oh yeah, for that one, yeah, no.
Yeah, I got
use calculator, no problem.
0.268 and 3.6.
Yes,
thank you.
No problem. You could use calculator.
Yes.
Because most of them have the function already
Yes.
embedded in the calculator. Is that what you're saying? No,
yes, yes, sir. Yeah.
Yes, no
Just
problem.
For sake of
No
time.
problem.
Thank you.
Okay. So that's no problem. Once you get those numbers, okay, you found them for me also. I'm going to use them as 0.268 for this one. Is this 0.268? This one is the other number, 3.73, I think. So you can find this with a calculator. You don't have to do this manually. Okay, no problem. Once you find two values, because it's plus or minus, you have to go back to analyze them in such a way. Okay, so what is the reference angle? Reference angle, x reference, I call it. Second function, tan. Where's my calculator? Gotta be in radians, right? Second function, tan of 3.73 is actually 1.73 309 kind. Is that what you get? Okay, so what is the second function? Tan of 2 plus root 3 is 1 point, yeah, so 3.1.309 is better actually. So then where is the tangent positive? Tangent is positive in the first quadrant and the third quadrant. So the other, this is x also, because it's not the first quadrant. The other angle becomes pi plus your reference angle, 1.309. So it would be 1.309 plus shift pi, and I got 4.451. So I have from here, I have from this case, x is 1.309, because remember this because our angle is on the first quadrant, the reference angle is as our answer 4.451. From here, then x equal to, the reference angle is already found. When is still positive? Is this still positive? Both of them are positive, right? No, we have to where is tangent of positive anyway? So the reference angle for this setting is x reference is tan inverse of this one, second function tan.
Is it 15 angle for that one? 0.268, the tan inverse of that.
Okay, we'll see. I'm using radians.
How about finding like degrees, and if you divide it by,
Converted. Yeah, that's allowed. That's allowed.
if we divide by 180 and then hit
Yes.
the fraction button, it will give us the fraction himself. We don't need to figure out.
Okay. By the way, is this 2.268 or it's 2.262?
Mine, I found it was 0.268. Even if you minus it, like 2 minus square 3, it will give you 0.268. I checked it.
Okay. Let's see. I just did that and I didn't get that. Oh, okay. That's good. Very good. So you're right. You can work with degrees and then convert them at the end by dividing them by 180. Okay, whatever you get, pi times 180. Pi multiply your angle pi by 180. You will get this, the angle in radians. Okay.
Or is it 57.1, the change between radian and degree, right?
Yeah, but yeah, that's what's 57.1 is 1 radian.
Yeah. So 1.309 multiplied by 57 will give us the in degree.
Yes.
I got
Yes.
5/12 pi for the reference angle for 1.309. 5/12 pi.
1.309. Yeah, no problem. Yeah, mostly it's when you have a lot of numbers, you don't have to express them in terms of pi. You shouldn't. Really, when you are like you're dealing with infinite numbers, so you're not worried about writing them all in terms of pi, except for the well-known angles like 30, 45, 60, and so on and so forth. But for any angle, you shouldn't be bothered. You should deal with a decimal notation. I think the back of the book they keep for the regular angles, but you can convert this in terms of pi. You got what?
70. I got in degree 75, the degree, and it's 5/12 pi.
5/12 pi. But I am not worried about that. This is good enough. Okay.
Okay, sir.
Okay. So x reference for this one, second function tan of 0.268 is 0.262, right? So this is the angle. So first quadrant, tangent is positive in again, and then x, this is also x. X would be then pi plus your reference angle.
It's 15 degree plus 180.
Yes. So 15 degrees what in radians? Because they ask me in radians, I have to do it in radians. It is actually 3.444 something like that. I don't. So this is 15 degrees, said 0.26. Okay, 0.262 times 180 divided by pi should give me in degrees. Yeah, it's 15 degrees. This is 15 degrees. What's 15 degrees in pi?
Pi over 12. Pi over 12.
Divided by 15. It's
Pi over 12.
yeah, pi over 12. So you could have said this as pi plus pi over 12, right? So it would be 13 pi over 12, right? So the answers would be again, therefore, answers would be in decimals. I got 1.309, x is 1.309, 4.451, and 0.262 and 3.404, or like Wissam, he helped us to find this one is 5 pi over 12. 4.4 is like what? 5 pi over 12 plus pi, which is equal to 17 pi over 12. 17 pi over 12. And then 0.262 is pi over 12. And then the sum is 13 pi over 12. These are the four angles which satisfy the equation they give us here. That makes sense? Or is there questions? I know, Trevor, you asked me, but you said never mind, huh? So, okay?
Sir, I have one question. When we have an angle like sine 2 theta, and the range is like for theta is from 0 to pi. So when they come and to solve for 2 theta, they will double the range. They make it 0 to 4 pi. So is this always like?
Always, yes.
And if
Because
you have 3
sine
theta,
of,
if you have 3
yes,
theta, we'll make it to 3.
actually, you know what's happening? Sine of 2 theta, or the function y equal to sine of 2x, has a period. So you see, sine of x, y equal to sine x, has a period. What is the period for this? It's 2 pi period. So for the period for the sine of 2x is always 2 pi divided by b, where b is this number. So the period becomes 2 pi over 2, which is equal to pi, see? So the amount of numbers when you are dealing with 2x, you're going to get is like you have four quadrants. So if this is a period, the period here, then for this one it was this, but it's now the number of solutions for this will be doubled than this one, because the plane is divided in where? Instead of, say, for example, you have 2 solutions here, you will have 4 solutions here, because the period is slashed by half. Then in one period you will get 2, but they ask you to find x between 0 to 2 pi. So at least in pi you have 2 solutions, and then in the other side of the period, which is you will have 2 other solutions, will be 4 solutions. I'm not going in there with some, but you understand what I'm trying to say?
Yes, and we have also to substitute them, all the solution onto the equation, because sometimes.
Yes, it's better to double check.
Okay, thank you.
Yeah, but I'm not going in detail on that, because actually what you brought as an argument is very, very important, because of the period analysis. The period, say for example, what is the period of a function y equal to sine of 4x? The period for this is 2 pi divided by 4, which is pi by 2. So this function is completely, say, the sine function from 0 up to pi by 2. It's going to be completely, it's going to complete its period, or it's going to completely be described between 0 to pi by 2. But if they say, okay, do it up to 2 pi, then you'll have what? Up to pi 2, pi up to pi, there is another one. Up to 3 pi by 2, there is another complete curve of the sine. And then, you understand? So there are like double. Anytime we have double the angle, then the number of solutions will be double. There will be many, many x values which satisfy this equation. But I am not going there. That's so much detail. Only what we want is a simple understanding of how to solve equations. Okay?
Okay, sir. There was an example on the book, and they did it like that without explaining.
Yes, I know, I
why.
know.
So
But I think we did in 128, in MTH 128, remember, y equal to, we
yes,
did this.
yeah,
A
I remember.
sine of bx plus c, we did. The period was what? The period was 2 pi by b, remember?
Yes, sir.
So then when you're dealing with sine of 2x, when there is a number here, because of the period being compromised, then the full circle is like, maybe at times, if the period is pi, then whatever we find for pi, on the other side also you're going to find them. So if there are two solutions here, there will be two solutions in here. It will be four angles. Okay, they did an example like that on the book. I didn't see. Yeah. I didn't pay attention.
Yes,
Thank
with eight solutions.
you. Okay, yeah. So yeah, that's true. What you said is right because of the period. Imagine they ask you to find a solution in the plane, and then they ask you to solve sine 4x. We know that sine 4x has a period equal to what? Pi by 2, isn't it? The period is
Yes.
2 pi divided by 4, isn't it? Pi
Yeah.
by 2. How many pi by pi 2s are there in this circle? 4 of them. You
Four.
will have two solutions here, two solutions here, two solutions here, 8 solutions you get. If you were about to directly go, it's equal to say a number. If you get sine of 4x equal to a number, for example, it's not only one solution. There will be so many solutions within that because of the period. So I think, do I make sense at all?
Yes, sir. You said you were not gonna go that far, right? So
No. Actually, many teachers, when they teach these chapters, they only cover the first two sections because they find it to behind if they do further. So I have done much better according to what I put on the syllabus. I have done enough. I think I am not going in detail into the period analysis. No.
Okay, sir. Thank you very much.
Yeah. Thank you. So I'm very happy that I did question number 17. It's probably the hardest question of all because first of all we have to deal with a quadratic function, and then we have to find all the numbers. And the numbers, if you give me with decimal numbers, is good enough. Is it okay, class? Everybody? Oh, Sterling has asked a question. I didn't even see. Is the proof sharing his screen? I cannot see it. Professor sharing. I am sharing, Sterling. Do you have an issue? Sterling, are you there? Maybe it's an old question then. All right. So we can continue. All right. Now, today, we're going to start chapter 27. This chapter will deal with derivatives of trigonometric functions. So this is differentiation. Differentiation of transcendental. Functions. Transcendental functions. Transcend. Okay, these functions are mostly trigonometric, logarithmic, and exponential functions. And I know the derivative of now so in 27.1 they only deal with derivatives of the sine and cosine function. All right, so I just want to give you the rules. D by dx of sine of u is cosine of u du by dx. This is one. The second one is d by dx of cosine of u is minus sine of u du by dx. Okay. Well, you can do this by you can prove them. The book has done it. You can watch it on page 833. The limit of f of x plus h minus f of x over h as h approaches to 0. If you consider this as sine of x both ways, right, you will end up having cos x, and then vice versa. The derivative of cosine, if you use cos Fourier for f, then you will get negative sine x. They have tried to prove that on pages on page I think 834 and 833, 834. All right, but because this is technical math, I will just directly take the result. That's my interest. I have is the result. So the derivative of sine is cosine of u du by dx. The derivative of cos is minus sine of u du by dx. So I'm going to give you, for example, just example. What are we saying? What is the derivative d by dx of sine of x squared, right? So your u is x squared. You understand? The derivative of sine, you should know, the derivative of sine is cos. Cos of the angle times the derivative of the angle, which is 2x. So this would be 2x cos of x squared. You cannot multiply these two, no, because this is subject to cosine, this is not. So you cannot combine them together, all right? So that's why I usually take this to the front, because I don't want to be confused of multiplying both x's in here. So this is the answer, right? So another example would be, what is the derivative of, say cosine of 5t minus t squared, for example. Cosine of an angle. This angle is a function, which is u, really. This. So it's not easy. In other words, you have a function, so you have to apply chain rule. But the cosine's derivative, we know what is the cosine's derivative. It is negative sine. It's a rule, negative sine. The derivative of cosine is negative sine of u. What is u? It's 5t minus t squared times the derivative of u, which is, by chain rule, the derivative of u. It's not minus sine u and stop. Multiplied by the derivative of u is what we're saying. minus sine of 5t minus t squared times the derivative of that, which is 5 minus 2t. So I think this will minus 5 minus 2t sine of 5t minus t squared would be, well, you can FOIL this into it, but it's okay. This would be the answer for it. So I'll take you to section, so the examples from the textbook. Say number, this is on page, section 27.1, page 836. So number 4, for example, the easy questions are the early ones, y equal to 3 sine of 7x. What's dy by dx? I'm not doing, could you help me what that is? What do you think the derivative is? Do it together with me. What's the derivative of 3 sine of 7x? 3 multipliers.
3, it's 21 cosine 7x.
Okay, I agree. Thank you, Wissam. It is 3. The derivative of sine is cosine of the angle times the derivative of the angle, which is 7. So that's how he got 21. He multiplied 3 times 7 because he cannot say 3 cosine of 49x. That's wrong. You cannot multiply those two numbers. I am warning you, because these are quite different. This is subjected to the cosine function. This is not. So that's why you prefer to take this into the front as a multiplier. So what you're going to get is 21 cos of 7x. Does it make sense? All of you who are in class right now, does that make sense? Is there anyone, I'm asking, is there anyone which doesn't make sense what I have done for question number 4? And if that doesn't make sense, which part, or I can repeat it, you can tell me. If not, then I continue. I'll continue. No question. Okay. So question number 6. What if we have s equal to 5 sine of 7 minus 3t? See, now the previous, the u was 7x. Now the u is 7 minus 3t. So that's where the complication starts. Of course, complication also starts also with the function. Is it sine x? Is it sine squared x? Is it sine cubed? And so on. But at this level, ds by dt would be 5. The derivative of sine is cos of your angle times the derivative of the angle. You got to use brackets when you have a negative multiplier. So this negative and 5 will give you negative 15 cosine of 7 minus 3t. That's the best we can do. Number 8, y equal to cosine of 1 minus x. So dy by dx is, of course, the derivative of cosine is, what did we say? The derivative of cosine is minus sine of the angle, right? First step, minus sine of the angle, and second step, multiply by du by dx. So, no, minus sine of the angle. I'm right. Minus sine of the angle, which is 1 minus x. This is your u. The angle is u. Times the derivative of the angle, which is negative 1. So it is negative 1 times negative, which is sine of 1 minus x. Right. So y equal to cosine of 6x squared plus 5. What is dy by dx? Of course, the derivative of sine is cos. The derivative of cos is what? Negative sine. So the derivative would be negative sine of the angle. You don't touch the angle until you finish finding the derivative of that. So the derivative of cos is negative sine of the angle times the derivative of the angle. The derivative of the angle is 12x. So this is negative 12x sine of 6x squared plus 5 would be the answer. Question number 12 is the same sort. Y equal to, a little bit complicated, really. 3 sine cubed of 2x to the 4 plus 1. Mind you, this could be written as, I think for me, I would have written this as 3 sine of 2x to the 4 plus 1 to the power of 3. This is a better expression for differentiation than this one. This is what many textbooks use, but they meant to say this. You know, the exponent is for the whole function, including the function, not only the function, but not the angle. This is the angle. But this is actually what they meant to write this. They want to avoid these square brackets. That's why they are putting the cube here. Really, but what they meant is there is no trig function without an angle. So when you say sine to the 4 of x squared, this means, well, when you write sine, you need an angle for it, which is x squared. So the 4 is representing the power of 4. Understand? I think you should realize cosine of cubed, say z, means cosine of z to the power of 3. That's what it means. So I think that is better to see the inside when you're finding the derivative. This representation is better for differentiation. So dy by dx simply is apply power rule. Remember, you have 3u cubed. The derivative of that would be 9u squared times the derivative of u. That's what I'm going to do. So bring the 3 up front, you get 9. Write the base, sine of 2x to the 4 plus 1, and then reduce the exponent by 1, 2, times the derivative of the inside, which is a little, quite a bit. The derivative of the inside is not 2x to the 4 plus 1. The inside function is the whole thing. So the derivative sign is cosine of 2x to the 4 plus 1 times the derivative of this, which is 8x cubed. So it's a chain rule and a chain rule. 2 chain rules before you finish. So here I can bring this up front. So 9 times 8x cubed is 72x cubed. So, and then I can okay, it doesn't matter. Sine squared of 2x to the 4 plus 1 cos 2x to the 4 plus 1 would be the final answer. Is that okay? Well, Silas, his agreement or no? Okay. Michael, wouldn't the function of sine be squared? Yes, you're right. I squared it. It's right here. But if you don't like that representation, you could have done it like that. No problem. Both ways are okay. Michael, both ways are okay. The textbook will never do the brackets in squared. The textbook, because they are professionals, they do it inside. Right? Both are good ways, but in the text, most of the textbooks in calculus, they never use this extra bracket to make it a square. What they do is they put it in here. It doesn't confuse. They have agreed not to be confused. This is what the same is true with logarithm of x, for example. Instead of doing this, most of them use log of that. So log of x to the or ln 4x to the power of 10 is represented as ln 10 4x. It's very common. The sine to the power of 10 2x. Just they're saving writing the brackets. That's all. I hope you understand that, because it's very crucial. That confusion creates a lot of ambiguity in the process. So I hope you followed me. I think through practice you will get the hang of that notation, no problem. In 14, they ask us y equal to 4 cos squared root x. You can rewrite this as 4 cos of the angle squared. That's what they meant, really. Then he finds the derivative. Instead of looking at this derivative, you would do that after you get experience. I would rather see this as a derivative right now. So, okay, apply power rule, bring the 2 up front, 8, write the base, cos root x, reduce the exponent by 1, times the derivative of the base, which is minus sine root x. You don't touch that until you finish this. Minus sine of the angle times the derivative of the angle itself, which is, what is x to the half derivative? The derivative is 1/2 x to the negative half, which is 1/2 root x. So I remember the derivative of root x is 1/2 root x, but you could do it that way, right? So dy by dx actually is, you can adjust it. You see, I have minus 8/2 root x, right? I put this times this, and then this. I put 8 times the minus this. 3 of them I multiplied already. Cosine of root x, sine of root x. Or you can do negative 8/2 is negative 4, cos of root x, sine of root x, divided by, when the 2 is gone, so root x. This is the answer. You cannot cross out the root x's. Be careful. This root x, the top root x, is subject to the sine and cosine. The bottom is not. So they are not the same numbers. Okay? Does it make sense? Okay, thank you. So there is a product rule, which is y equal to 6t squared sine of 3 pi t. Product rule, there is one u, this is v. You know the product of u v derivative, u prime v plus u v prime. That's what I'm going to apply. dy by dt then is the derivative of the first, which is 12t, times the second, which is sine of 3 pi t, plus the first 6t squared, times the derivative of sine, which is cosine of the angle, times the derivative of the angle, which is 3 pi. The derivative of 3 pi t is 3 pi. So this is 12t sine of 3 pi t plus 18 pi t squared cos of 3 pi t. You can factor, I think, 60, I think it's common, but you don't need it. For what? You factor only to simplify. But at this level, this is good enough answer, you know. I'm going to repeat the derivative of the first times the second plus the first times the derivative of the second. In finding the derivative of the second function, which is v, it is actually the derivative sine, which is cos of the angle, times the derivative of the angle, which is the derivative of kx is k, you know, the number multiplying the t. So the number multiplying the t here is 3 pi. And then on writing the answer, I got 12t sine of 3 pi t is copied, but 3 pi times 60 squared is 18 pi t squared. So I want to do one example of quotient rule. So like number 25, for example. I know it's an odd number, but it's a good example for the quotient rule. So you know that this is u over v, right? The derivative is the top derivative times the bottom minus the top times the derivative of the bottom over the bottom squared. dy by dx is the derivative of the top. Then remember, cosine of x squared and cosine squared x are different. They are not the same. In here, we are told that the angle is squared, the x is squared. In here, the function is squared. This is cos x the whole square. This is cos of x squared. Completely different. This is easier derivative. This is not. This is chain rule involved in there. Both are easy, but anyway, the derivative of this is 2 cos x times minus sine x. The derivative of this is minus sine of x squared times the derivative of x squared, which is 2x. I don't know which one is hard, which one is, but we will do it in the as part of the question. All right. So what I'm saying is the derivative of the top is 2 times the derivative of cos is simply minus sine of, there is no exponent here, so there is no power rule applied there yet. At least for the cosine, it's exponent 1. So there is, you just go straight to the derivative of cos is negative sine of the angle times the derivative of the angle, which is 2x. That is the derivative of the top times the bottom. Remember, times the bottom, which is 3x minus 1, minus the top, which is 2 cos of x squared, times the derivative of the bottom, which is 3. The derivative of 3x minus 1 is 3, over the derivative, the denominator squared, which is 3x minus 1 the whole squared. It's always following the rules one at a time, okay? The derivative of the top function times the bottom, the top function times the derivative of the bottom divided by the bottom square. So I think a little bit simplification. So it is this 2x, I can multiply this 2x with these 2 to give me minus 4x, because this is a minus 2, right? Minus 4x sine of x squared times 3x, or I could even bring the sine, so 3x minus 1 times sine of x squared. I took care of everything, minus 6 cos x squared over 3x minus 1 the whole square. You can multiply these two, but it's okay. You can leave it the way it is. Because there is no 3x minus 1 here, you cannot cross this by this. No. Because you need 1 in here to cross out. I think the last question is okay. Any suggestion? Technically, I'm done for the class. So you can ask me questions.
Sir, for question 16, we have 18 pi. How much is the value of pi in this case? Because it's a derivative of an angle, right? 18 pi. You have 18 pi. So how much is the value of pi? It's the derivative.
Pi is a number,
it's not an angle anymore.
It's not an angle in this case. It's just a real number.
Okay. 3 point.
It's 3.14, whatever. But otherwise, I wouldn't do 3 times 15 degrees. 3 times 15 degrees is not compatible. 15 degrees measures an opening of 2 rays, but the two cannot, like, I mean, it doesn't make sense. That's why we need radians all the time in calculus, so we can multiply them. But we can multiply or divide with the real numbers. So I think that pi is not an angle. It is actually a real number. Where is its position in the number line? Okay, here it is. There is 0 here. There is 1. There is 2. There is 3. There is 4. It's an irrational number somewhere. 3 is somewhere in here. Just like root 2. Root 2 is 1.4144, whatever. Like it doesn't stop. Where is the position? It's like here, 1.41, right?
Actually, it's the value of the pi in radian. It's like 180 divided by 57, right? So it's 3.14.
It's not exactly 3.14. It is actually an approximate
Yeah,
3.
it's 22 over 7. Maybe that is better.
Yeah, well, that's not exact. Pi is not 22 over 7. It's not. Pi is an irrational number. You cannot write it as a fraction. That's the best approximation.
Yeah, approximate.
I mean, I want to be very. You're not wrong. Everything is what you're saying is right, but you got to be careful. Pi is an irrational number. There is no. What is an irrational number by definition? A number that cannot be written as a fraction. That's what irrational number is.
I mean,
Irrational number is.
that is better than 3.14, 22.7.
Yes, I agree, but that's the best approximation. So we should say approximately equal.
Approximate, yeah, approximate.
Yeah.
Oh.
Yeah. So I think the pi in this case, I wouldn't consider it as an angle. I will consider it as a real number.
Thank you, sir.
You're welcome. Is there any other questions? Please ask me. Ask me. This class is yours. You should ask. Sivan, thank you. Have a great day. If you are leaving, I know some of you left. I know it's time.
Homework?
Sorry?
Can you give us homework?
Yeah, it's from questions 3 up to number 3 up to 25 odd. It is on page 836.
Thank you, sir. Have a good day.
You too. Thank you. Have a great day. I will post the. Thank you, Dima. Thank you, Sam, and everybody. Thank you for coming today. Have a great day. Catherine, thank you. Right, Kramer, thank you so much for the question you brought. Yeah.